Let's take a few minutes and look at dividing radicals. Um, there's some little quirks and bumps along the way. Once you figure those out, it's not going to be a big deal. It's going to start out very, very small and pretty easy. So this first problem here, if you've got the square root of 36 over the square root of 25. I mean, the reason it's called division, I mean, obviously it looks like a fraction, so all of them are going to have that look about them. So nobody needs to press the panic button just because you see radicals in fraction form. It's just division, no big deal. If you can reduce, then just reduce. The square root of 36, you guys know that, that's just 6. And the square root of 25 is 5. You're done. So don't make it harder than it is. Okay, now let's upgrade just a little bit. Okay, this is an upgrade in the fact that you've got cubes, but you really can't do the cube root of either 32 or negative 4. So that in itself is a little weird. But keep in mind, you can do your other operation first. Do you remember a while ago, if you've already gone through the multiplying part, we did stuff like this. We did, let's see here, we did square root of 3 times the square root of 6, and then we multiplied them together, and then we broke them down from there. We did the multiplication before we broke down the radicals. Well, we're going to do the same idea. We're going to do the division before we break down the radicals. So you can actually rewrite that in a different way. Instead of doing separate radicals, you can do one large radical. Now actually do the division. And you don't have to rewrite that if you don't want to. It's just a little bit easier to see, oh, it's permissible to divide. So what is 32 divided by negative 4? Okay, that's going to be negative 8. Well, can you do the cube root of negative 8? Yes, you can. It's okay to do cube root of a negative. You're just going to get a negative, and the cube root of 8 was 2. So we've got that answer. Even though it started a little weird, you can do it. Just remember, do the division part first, and then try to break down your radical. Okay, we're going to use that same ideology on this problem. We're going to do the division part first. Then we're going to work with our radical. So we don't necessarily have to rewrite that as one large fraction. Let's just think, what is 162 divided by 3? I don't know, so I'm typing it in. I'm going to get a 54. Now I need to leave that under the cube root. Now, if you remember, if you're dividing like bases, we're going to subtract our exponents. We have 5 on top minus the 2, so we get x to the 3rd. So we need to break down this radical. Now, I can't do the cube root of 54, but I do believe 54 is 27 times 2. And I can do the cube root of 27. That works out well. So now my powers look great because I can divide 3 by 3. So all of these x's can go. So everything is sorted out nicely. I need to take the cube root of this. Cube root of 27 is going to give me 3, and I'm going to divide my powers. And then I've got my 2 stuck under here. Now don't forget your little cube. I've confessed to y'all I have trouble keeping up with my little cube, so we have to remind each other about that. But there we go. That's been reduced. Okay. Now those were the ones that come out nicely. But what happens when it doesn't? Because I call it math etiquette. There's certain things in math that you're just not supposed to do. You're not supposed to leave a fraction that hasn't been reduced. You're not supposed to leave a negative in the bottom of the fraction. It should be written in the top or out front. But it's bad manners in math to leave a radical in the denominator of a fraction. You're just not supposed to do that. So you need to write it in an equivalent form. You're not changing the value. You're just changing what it looks like. So we need to manipulate what this looks like, because this square root of 2 over the square root of 3, we can't leave this guy this way because this square root of 3, he's just not allowed to sit in the denominator. It's just not right. So here's the rationalizing process. What we're going to do, it's kind of a devious little plot. You're going to take whatever this radical is, going to come over to the side, stack him up. Now, think about why you did that. The square root of 3 over the square root of 3. What is that equal to? Isn't anything over itself 1? So this ugly little fraction that you just created is really just equal to 1. So if you take something and you multiply it out by 1, did you change the value? No, you didn't. So even though we're multiplying by this ugly fraction, we're really multiplying by 1. The value will not change, but it will most definitely look different, and it will give us what we need. Okay, and let's go through this so we can prove our point. What we need now is for the square root, the radical, to go away in the denominator. So, now, hopefully you remember when you multiply fractions, you multiply straight across in the top and straight across in the bottom. Don't get confused. When you have an equal sign in between two fractions, that's when you cross multiply. We don't have an equal sign. We have multiplication. So you go straight across. Now, remember our rules? Outsides go with outsides and insides go with insides. So the square root of 2 times the square root of 3, that will be 2 times 3 is square root of 6. Okay, now here we go. The square root of 3 times the square root of 3. Now, I'm probably not going to write it like this every time, but let's just think through it this time. 3 times 3 is 9, right? Okay. Now, what is the square root of 9? That's just 3. Now, before you jump the gun and start reducing that fraction, press the pause button for me. Do you remember my crazy little rule? Outside numbers play with outside numbers. Inside numbers play with inside numbers. 6 is an inside number. 3 is an outside number. They don't play together. So even though they look really good and you're thinking, ooh, 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 I could reduce that 6 and 3 and get a 2. No, you can't. Because 6 is a radicand and 3 is a coefficient or a constant. You can't reduce those. This is your answer. Your problem is complete. So stop right there, okay? But you got to remember, outsides go with outsides, insides go with insides. Okay, let's get one a little bit more complicated. I would highly suggest that we go through the process we did earlier and use the division idea first. You couldn't divide up here. There was nothing in common with 2 and 3, so trying to divide would not have helped us. But here, if you see, we've got x cubed up top. There's an x there. So if we try to divide, it's going to help clean it up just a little bit. So if we go through and divide, let's see here, that's going to take out one of the x's. And this will become x squared, and this will become 5y, because I'm going to, remember when you divide like bases, you subtract your powers. So does everybody see that I reduced basically one x out of the top and out of the bottom? Okay, now you can rationalize, because you simplified it first. Now, same idea as what we did in the top. It's just a little messier in the bottom. I need, my radical has square root of 5y. Well, whatever is in that radical, you're going to stack him up. Okay? If it's the same thing, this is 1. You're not changing value. Now, start multiplying across, straight across. Insides with insides, so just put them all in there. X squared, and this is going to be, oops, you know what, it'd probably look a lot better if I did my 5 first, and then my x squared, and then my y. That'd look better, wouldn't it? Okay, and then when I get down to the bottom, I've got the square root of 5y times the square root of 5y. The more you do this, what you're going to learn is when you multiply a square root of a term times the square root of the same term, guys, what you get is the term that's underneath. You will always go around, it's kind of like going around in a circle, like what we did up here. The square root of 3 times the square root of 3 gave us the square root of 9, which was 3. So down here, it would have been the square root of 25y squared, which is 5y. So the shortcut is knowing, oh, if I multiply these two things and they both are the square root of the same term, just take the radical off. Now, you do need to clean it up just a little bit because this guy needs some attention. And you could have done it earlier, I just didn't think about it. The square root of x, x squared you can do, because his exponent you can divide by 2. So he goes out, you cannot do anything with 5y. And now you have the 5y in the bottom. Question, can you reduce your 5y's? I'm hoping to goodness you said no, because the top one is an inside 5y and the bottom one is an outside 5y. You are done. Okay? Now I should have put absolute value bars around him. Remember when you do square roots of variables, you're supposed to put them in absolute value bars. Shame on me. All right, now this is the nasty version when you do a cube root. So if you're not having to work with cube roots, you may not want to watch this part. If you do have to do cube roots, you may have to watch it several times. There's nothing that you can really reduce by division process because 2 and 3x don't have anything in common. So to get started with this, you kind of have to think about what we did earlier. Remember, if it's a cube root, that means we have to have 3 of everything to get 1 out. Okay? Well, currently I have 1 3 right here, and I have 1x. But I need a cube root. I need 3 3's, and I need 3 x's. So I need 2 more. So I can't just multiply by, like the cube root of 3x. I can't do that. That won't give me enough. I need to multiply by, and it just kind of depends on how you want to write this. I'll tell you what. There are various ways that you can put this down. I'm trying to figure out how I want to write it. Let's do this. 3x squared and 3x squared. How about that? It's all got to be cube root because our roots have to match for us to be able to multiply. So roots must match. But I need 2 more. So that's my logic in wrapping these things up and putting the square. All right? When I do that, what you might want to do is figure out what that's equal to. So I think what I need to do is, instead of doing this, I'm going to copy down what my original was. And what does that actually equal? What is 3 squared? That's 9, and x squared is x squared. And that's going to give me the same thing in the bottom. So, once I multiply these, I should be able to get rid of the cube root in the denominator. Okay, so I need to multiply my tops. And when I multiply my tops, I'm going to get 2 times 9 is 18x squared. That's the cube root of that. And in the bottom, I'm going to have the cube root. And guys, you can go from one big radical to 2 separate radicals anytime you want. Let's see here, 3 times 9 is 27. And then I've got 1x here and 2 x's there. That's my devious little plan. So this is where my little plan, my little conspiracy came together, because I'm trying to get it to where this right here is a perfect cube. I want to be able to take the cube root of this and everything just come out beautifully. So, let me wrap this up. In the top, you can't do anything with this. You got 18x squared, and in the bottom, the cube root is 3x. You cannot reduce, because these are insides, these are outsides. You are stuck. This is your answer. Hope that helped. Come see me if you need a little bit of extra help on the side.